Okay, here we are in MATLAB now, and let's calculate some complex numbers, and let's run the examples based on the things I did on the board in the previous video. Now, one of the first things I said was that the root of the function x squared plus 1 equals 0, or complex, it's actually imaginary because the real part is 0, and I tried to draw on the board that if you plotted it in the real imaginary axis, you could see the roots. Well, let's try that. What would that look like in MATLAB? Probably the easiest way to do it is with an anonymous function. And so I'm going to assume that the complex value is a plus ib. So a plus ib, and I'm going to square that and put that dot in there because it's going to yell at me if I don't. Now, one thing here, I'm putting complex numbers in. The independent variable is the complex number a plus ib, and I want to plot the real versus the imaginary part. That's going to take 2 dimensions. Now, f is also going to be complex. Well, if I want to plot 2 dimensions in and 2 dimensions out, that takes 4 dimensions. I don't know how to do that. I don't know about you guys. I live in 3-dimensional space. I'll bet you do too. So rather than face that, I'm going to plot the absolute value of f. So I'm just going to do this. The absolute value of a complex number is real. So there. Now I've got the absolute value of x squared plus 1, where x is a plus ib. All right, let's me do that. And there is an, let's do f surf first. This is cooler as a surface plot. Let's pull this down here. Maybe make it a little bigger so you guys can see that. There we go. Be able to rotate it. And there's these 2 little feet that come down. See that right there? There we go. See that right there and right there? What are those little feet? Well, those are the roots. That's what they look like. Now, which one of these is real and which one of these is imaginary? Which axis? Well, let's go ahead and label it. Since I said a plus ib, the first value, a, is real. And let's say y label. That's going to be imaginary. And let's bring that plot back up here where we can see it. Okay, so we can see the real and the imaginary. If we look here, you can see that those 2 little feet are at +1 and -1. Well, that's plus I and minus I. That's exactly where we thought they were. Now, it's kind of cool here, but it's not always very easy to see, to pull numbers off of that. Can you do F contour? You bet. And let's go from -2 to 2 in the real and -2 to 2 in the imaginary. And you can kind of see it here. Let's turn the grid on as well. All right, so you can kind of see what's going on. There's a cool little sort of figure 8 in here. And you can see that the root's probably there and probably there. Well, yeah, it's okay, but it would be nice if I could zoom in a little farther. Well, you can. What we can do now is click there and just double click on the plot. And you can see down here there's a thing called level step. Level step is the vertical distance between contour lines. And I messed around with this a little earlier. If you say level step of 0.5, now you can see where the contour lines are going to home in on that point. Let's go make it 0.25. Let's double the number of lines pretty much. And you can see now that right there, 1i and -1i, that's where those little feet were. So those are the roots of that equation. They're easy, easy, easy to see as long as you plot it correctly. Let me turn that off. The reason we couldn't see it on that XY plot is because we insisted on saying X was real and the vertical, the Y, was the dependent function, the value of the function. And so in this plot, it's actually along this plane right there. The reason we couldn't see it wasn't because it wasn't there, it was because we just weren't looking in the right place. So we've solved that problem. Let's get rid of that. Let's clear the workspace, clear the command window. Okay, now multiplying and dividing numbers in MATLAB is just dirt simple. Let's go ahead and multiply that example I did on the board. Multiply two numbers. Now, I is built into MATLAB. It already knows what I is. And so there we go, same answer I got on the board, fortunately. Let's go ahead and divide. Okay, again, the same answer, so no problem. About the only place you can get yourself in trouble is if you reassign I as something else. Well, do people ever do that? Sure. Now, you wouldn't do this on the command window, but have you ever typed in a command that looks like that? If you type that in, you've just assigned I as a variable you're using to count through a loop. It doesn't equal the square root of -1 anymore. So when you write your M files, if you know you're going to be working with complex numbers, make sure you don't reassign I. That's going to be bad. Now, as a little teaser for the next video, could you take the square root of a complex number? Sure you can. SQRT, squirt if you want to call it that. There. Whoa, wait a minute. What? 1 plus I. That's a nice, simple number. 1 and 1. That looks so tidy and so friendly. But this is what comes out? Oh dear. Well, Well, let's go to the next video and figure out how that is, because it's clearly true. Let's figure out how you find that weird number from what looks like a simple one. So let's move on to lesson 18.